Okay, so yesterday I gave you guys a question paper. Did people go through it? Did people go through that question paper? Hello? All right. So the first question was asking us to indicate whether each of the following numbers is rational or irrational. So yesterday we said that for irrational numbers, we are looking at non-terminating decimals. For rational numbers, we are looking at numbers that we can write as a fraction where our denominator is not equals to 0. So this includes fractions, also includes recurring decimals. Like that. Right. So now we have to check, is 8 rational or irrational?
Rational.
It's rational because we can write it as a fraction, can be 8 over 1. So this is rational. So this is rational. Right, and then 2 over 3 multiplied by pi. Rational or irrational? Is pi rational or irrational?
Irrational.
Irrational, because this 3, 1, 14, whatever, it goes on forever and ever. So if you're going to multiply it by this number over here, it's still going to continue being an irrational number. So this is irrational. And then 6 over 7 plus the cube root of 8, is that rational or irrational? Rational or irrational?
Irrational.
All right, let's check. So you have 6 over 7 plus the cube root of 8 is just 2. So this is just 6 over 7 plus, I think this can be 14 over 7 like that, and then you end up with 20 over 7. So this is a fraction. We can write it as a over b. So this ends up being a rational number. So this is rational. Do we understand that part? Right, question 2. So far that was all for 3 marks. Question 2. We have to apply laws of exponents. Question 2, we're looking at laws of exponents. Is someone saying something? Okay, right. So for this one, you have to remember the laws of exponents, whereby we say, when we say that anything raised to exponent 0 is equals to 1. So that means this is just going to be 1, right? Then you look at this one, it's negative 1 over negative x raised to negative 1 like that, right? So the negatives over here, this one and that one will cancel out. Here, we have to change this to have a positive exponent. So you have 1 over, and then this, remember, it's just going to be 1 over. Let's make that with a different color so that you can see that this 1 belongs here, like that. So this part is this part in the denominator over there, right? And then now we have to rewrite this. So this 1 over 1 divided by 1 over x. Is everyone clear about this part? This is this 1 divided by 1 over x. So this is 1 divided by 1 over x. Then from there, we can change the division sign to be multiplication. If we do that, we flip whatever is on our right here. So this will be x over 1. So we end up with just x over 1, which is x. So that means all of this is just x, like that. Right, and then the last one over here, we are given 9x plus 1 times 5x plus 2 over 45x plus 1. So the first thing you try to do is convert everything into its prime factors. So prime factors, remember, you're going to take the number that you're given. So this will be 9. You press equals to, and then from there you press shift, and then you look for the button return fact on your K-show calculator. And then what do you get for 9?
3 exponent 2.
So it's 3 exponent 2. This is 9. X plus 1, like that. And then for 5, will 5 have any factors, or is it a prime? It's just a prime number on its own.
It's a prime number on its own.
So it's just going to write it as it is. All right. And then for 45, what do we get?
3 exponent 2 times 5.
3 exponent 2 times 5, like that. And then this is x plus 1, like that. So we have done the first part. We have converted everything to prime factors. Next, we have to multiply. We have to apply this law that says if I have an exponent raised to another exponent, I just multiply those exponents. Another one that we have to apply is that if I have something like this, let's make this p, and then there's the exponent m out here, a with its exponent will multiply whatever that's outside, b with its exponent will multiply whatever that's outside. So these are the two that we will apply on our next stage. So that means we'll have 3 exponent 2x plus 2 times 5x plus 2 over 3 2x plus 2. So this is that part over there. And then times 5x plus 1, like that. Everyone happy so far? We just multiplied this exponent with that exponent. The exponent here is 1 with this exponent. This is what we get now. Then from here, remember, we just keep one base. So for 3, we keep 3 like that. We take everything that has a variable. So right now we are using this exponent over there. So there's nothing else that has 3 on the numerator. So we check the denominator. We have a 3 here. It has that exponent. So remember, if it's in the denominator, we are subtracting like that. So we are done with everything that has a variable with a base of 3, like that. Then from there, we check 3 with exponents that don't have a variable. That's that one. There's no other 3 over here. We check the denominator. We have this one over here. So it will be minus 2 because it's in the denominator like that. We move on. We have 5. X, there's no other 5 over here that is exponent, that's a variable. We check below, we have 5 exponent x like that, so this becomes minus like that. We are done with that one. We have 5, we have this exponent which is 2, and then you have this exponent which is 1, so it will be -1. It's minus because we are dividing over there. So this is what we have. So this ends up being 2x minus 2x gives us 0. This ends up being 2 minus 2 gives us 0. X minus x gives us 0. We are left with 5, which is exponent 2 minus 1, which is just 1. So this is 1 times 1 times 1 times 5. So our answer is just 5, like that. Any questions on that one?
Nope.
All right, so remember you should test if your answer is correct. Yes, remember to test if your answer is correct. So you can use x being 0. So 9, 0 plus 1 like that, times 5, 0 plus 2 over 45, 0 plus 1, and see if you're getting 45. Can we try it? You're supposed to get 5 actually here. That's the answer we got.
It's 5.
We're getting 5, so that means our calculation was correct. So remember, the number that you have to substitute here can be any number. So sometimes I would advise you can check before or after in terms of what you're supposed to get at the end, so that you can see that you have already made a mistake somewhere. Yeah. All right. Question 3. You are asked to factorize the following completely, right? So for the first one, you have 3 terms. So it's 2x squared minus 14x minus 60. Like that. So mind you, we don't have any equals to 0. So this is the expression we have. We don't have an equation, right? So even though it's a trinomial, I can see that there's a common factor that I can take out here, which is 2. So it will be 2 into x squared minus 7x minus, I think it's 30 over here, right? We don't throw away this 2. We keep it with us. There's nothing here to say we have divided by 2 both sides. We don't have this side over here. So we keep that 2. We don't throw it away, right? So this is a trinomial. Open 2 brackets like that. We're looking for factors of 30 such that when we add or subtract them, we get 7. So factors of 30, you have 30 and 1. You have 15 and 2. You have 5 and 6. What else? 10 and 3. Is there something that we are missing?
No, sir.
All right, so let's check adding, subtracting. So if we will add, this is 31, 29, 17, 13, 11, 1, 13, and 7. So we are looking for the one that will give us a 7. That means we'll be using 10 and 3. So I have x, I have x, I have 10, I have 3, like that. So the sign of a bigger number, it's negative, like that. This one is telling me that the signs are not the same. So if I already have negative, this will be plus. Then from here, there's nothing more I can do. This is my final answer. We are done. The 2, you don't throw it away. Any questions on that one?
No, sir. No, sir.
All right, 3.2, a given 1 over 8 x cubed plus b exponent 9, like that. So this, if you plug in a cube root here, you get 1 over 2. So this is a perfect cube. This one you get 1, you just get x if you plug in a cube root. This one, if you plug in a cube root, you just get b exponent 3. Yeah, like that. So it's also a perfect cube. So that means you just open 2 brackets, a small one and the bigger one. So this becomes that. Remember the first bracket, you plug in whatever that you get after applying a cube root. So here, in terms of how did we get 3, we have a law of exponents that says if I have the nth root of something, it's just gonna be a exponent 1 over that. So here I was just having b 9 like that, 1 over 3. So it ends up being b 9 over 3. So 9 over 3 gives me 3. So that's why we have this one over there like that. After here, you just square the first term over here. So this is 1 over 4 x squared. This is us squaring the first term. So we took 1 over 2 x squared like that, right? And then the last term over here, we are squaring this guy over here. So it's going to be b cubed, and then we square it. So we end up with those two multiplying, we end up with b exponent 6. Then the middle term is just this one times that one, which is 1 over 2 x b cubed, like that. Then in terms of the signs, I was given a plus, so I'll put a plus in the first bracket, and then I'll have a minus and a plus. Remember, you always have one negative. If I was given a minus here, I'll have a minus, plus, plus, like that. Any questions? This ends up being your final
No,
answer.
sir.
All right, this ends up being your final answer, like that. And that was for 2 marks. Right, moving on. Question 4. Question 4 is a solve for x question. So you have an equal sign over there. So we're given 2 minus 3x equals to 6 minus 4x, like that. You can take everything with a variable one side. 4x minus 3x equals to 6 minus 2. This ends
I
up being,
say, Mila, I'm having technical problems by my side.
what's happening? Can you hear me? Hello? If you're having technical problems, can you just exit and join in again? Can everyone else hear me and see the screen?
Yes.
Yes, sir.
All right. So here we have x is equals to, this gives us 4, like that. So this is our final answer. So remember, we have to check if our right is equals to our left. So it will be 2 minus 3 into 4. So this will give me 2 minus 12, like that. This gives me minus 10. So on my left hand side, I have minus 10. So I'll have 6 minus 4 into 4, 6 minus 16, and then this is minus 10. So my left and right are equal, means this answer is correct. Next, we have 4.2. 4.2, we are dealing with fractions, addition and subtraction of fractions. So we have x over x plus 2 plus x over 3 minus x equals to
Guys,
3.
can we ask questions that are out of the test?
Okay.
Can I ask after?
Yeah, you can.
I must ask now.
No, you can ask us after, it's fine.
Okay, thank you.
All right, and then from here, these are fractions. Remember, we cannot add or subtract fractions if our denominators are not the same. So we need to find our LCD. But firstly, before we can do that, I would suggest that we try and factorize this guy over here and see what we have. So it's x plus, here it's x over 3 minus x, it's equals to that this is a trinomial. I end up with x plus 2. Sorry. All right, so this is what I end up with when I factorize that denominator over there. So as you can see, the x plus 2 part, it's already represented this, just as rearranging it like that. So that means this guy is sorted. This x minus 3, we can get this x minus 3 from this guy if we take out negative as our common factor, like that. So that means our LCD ends up being minus x plus 2, x minus 3, like that. So every part of the denominator is represented. Here I do have x plus 2, x plus 2, a negative, x minus 3, x minus 3, x plus 2, x plus 2, x minus 3, x minus 3. So every part of the denominator is represented. That's what the LCD is supposed to do for us. Right. After doing that, we now check that if I'm gonna close this denominator with that denominator, isn't like I close the similar things, I'm only left with negative and this bracket over here. So I take all of the things that are remaining and multiply with whatever that I have in the numerator. So I'll have minus into x minus 3, all of this times this x over there. I'm done with this part. I move on to this guy. So this guy is just this. So that means I have to highlight or close off the negative and this bracket. I'm only left with x plus 2. So that means here I'll have plus x. This x is the one that was originally there. And then the x plus 2 is from the denominator over there, like that. So we are done with this guy. Equals to this side. This guy is that guy, this guy is that guy. That means I'm only left with the negative. So that means I'll have minus times whatever that will be on the numerator. After that, I can now throw away my denominator because I've used it throughout. So if I multiply here, I end up having minus x into x minus 3 plus, this is x squared plus 2x equals to minus 3x plus 2, like that. This is minus x squared plus 3x plus x squared plus 2x equals to, we can actually just bring these guys over, plus 3x minus 2 equals to 0, like that. And then we can take note of our like terms. So this one and that one, same variable, same exponent, are like terms. This guy, and that guy are like terms. This one doesn't have a like term. So here, if they are like terms, remember, you just take the coefficients. So I have minus 1 here, plus 1. So it gives me 0. So these guys are no longer there. For these other ones, I have 3 plus 2 plus 3. So this gives me 8. So I have 8x and then minus 2 equals to 0. And then this is 8x equals to 2. I divide by 8 both sides. My x is equals to 1 over 4, like that. Any questions on that one? Any questions? All right, I assume that silence means everyone is sorted. Right, so you can check that if you're going to plug in this value into wherever you have x, your left-hand side has to be the same as your right-hand side. So you can do that on your own. Right, that was for 5 marks. Next, we have an exponential type of question. We have 3x times 9, 2x plus 1 equals to 81. So first thing we do, change everything to its prime basis. So here I'll have 3 exponent x What do I have here for 9? What do we have for 9?
3 exponent 2.
3 exponent 2, like that, and then 2x plus 1 equals 2. For 81, what do we have?
3 exponent 4.
3 exponent 4, like that. So now let's see. So this is just 3x times 3 exponent 4x plus 2 equals to 3 exponent 4, like that. Right. So let's carry on. So here, same basis. We are same basis. We are multiplying. We can add the exponents. So I'll have 3 exponent 5x plus 2 equals to 3 exponent 4. So now I have the same basis being equated. I can just equate the exponents. Therefore, 5x plus 2 equals to 4. And then from here, just 5x is equals to 4 minus 2. 5x is equals to 2. I divide by 5 both sides. My x value is 2 over 5, like that. So you can plug that in to the original question to check if your left-hand side equals your right-hand side. All right, any questions on that one? That was for 3 marks. Okay, I assume silence means there's no question. Lastly, we have an inequality there, minus 4 it's less than or equals to 3x minus 1, which is less or equals to 5. So we're solving for x as well. So remember, for inequalities, we are going to get a range of values, right? So remember, we have 2 inequality signs. Whatever I'm going to do this side, I have to do this side. So I have minus 4 plus 1, 3x plus 1, like that. So this is minus 3x, 6. I divide by 3. This is minus 1 less than or equals to x less or equals to 2, like that. So this becomes my solution. Then if I'm asked to represent this graphically, that means I'll have a number line like that. These have an equal sign, so we have to shade our circles. This is minus 1, this is 2, and then we're just going to join those like that. And then this is my final answer, if I was asked to put this on a number line. Any questions on that one? All right, question 5, it's patterns. You guys are only doing patterns, I think, term 4. So,
Okay.
yeah.
I wanted to ask a question for solve X. So if there's a bracket like 3x minus 5 equals 2, open bracket 3x minus 1.
Let me write it
bracket,
down. You said, what's the question?
3x minus 5 equals 2. 2 open bracket 3x minus 1 close bracket. By the bracket side, do I say 2 times 3x and 2 times 1 negative 1?
Yes.
Oh, that's what I wanted to ask. So
Okay. All right. So question 5, I said we're not doing it because I don't think you guys have done patterns at your schools. If you do get a question for patterns, they are expecting you to use your knowledge from grade 9. Right. Question 6. So here you are given two graphs, which is f at x. F at x is marked there. It's the parabola. H at x is marked here. It's the straight line.
It is. Oh, I told him.
What we can see here, we can see the turning point of the parabola. It's at 0 and 0.
Yes.
We can see the x-intercept of h is at w here. You can see the y-intercept of h is at b, like that. We can see point D is the point of intersection. Both those lines touch over there, like that. So firstly, they're asking us to find the equation of the parabola f. Right, so let's see. So it's going to be y equals to ax squared. Right, so we cannot substitute this turning point 0 and 0 because it's just going to be 0 equals to a0 squared. This is just 0 equals to 0. It's not helping us solve anything. So we're going to substitute point D because it's also on the line. So sub point D, which is 3 and 4. So this will be wherever I'm going to see y, I'm going to plug in 4. Wherever I'm going to see x, I'm going to plug in 3. Like that. So here I end up with 4 equals to 9a. I divide by 9 both sides. I end up with a is equals to 4 over 9. So that means the equation of f at x, it's just 4 over 9 x squared. So this is the actual equation. All right, any question regarding that one? So the only part was for you to identify that there's a point on the line you can substitute to the original equation for you to get the unknown value, which is a over here. So this is what you have. 6.2 is asking us to calculate the coordinates of C if the equation of the parabola is that. So this question is sort of guiding you that whatever that you were actually supposed to find the equation of f to be that. So they're helping you not to get everything wrong. You might have gotten this part wrong, but now if you're using this, that means you're able to get this one correct and that one correct and so on. Right? So C is also another point of intersection. So point of intersection, remember we just equate the equation of f and the equation of h. So you say f at x, it's equals to h at x. So f at x, we said it was 4 over 9 x squared. It's equals to 2 over 3 x plus 2, like that. And then we just bring everything to one side. 4 over 9 x squared minus 2 over 3 x minus 2 equals to 0. Then let's see how can we try and solve this. Let's try and get rid of this 4 over 9. Getting rid of this 4 over 9, we can multiply by 9 over 4 here. We can multiply by 9 over 4. We can multiply this by 9 over 4. We can multiply by 9 over 4. So this ends up giving us x squared minus, this is going to be 18 over 12x minus, this is going to be 18 over 4. It's equals to 0. So this is what we have now. Let's see if we can simplify it further. X squared, this is just going to be 9 over 6x minus, this is going to be 9 over 2, like that, equals to 0. So now we have to try and factorize this guy. So we're going to be looking for factors of this 9 over 2. So 9 over 2, it's just 4.5. Right. So let's see if we can get factors of 9 over 2, 9 over 2, 9 over 2. All right. This is going to be a horrible calculation, but let's try it. Right, so this will be x and x. We are looking for these factors such that when we add or subtract them, we get this guy over here. Right. So let's see, how can we make 9/2? It's a fraction. We can have 9/2 times 1. We can have 3/2 times 3, like that. We can have, is there something else we can do? Nope. Is there anything else that we can multiply to get this? Anything else? All right, I guess this is it. Let's try and see if we do get that 9/6. It's gonna be a tricky one, but let's try. So if we're gonna add here, if we're gonna subtract there, so adding here, just gonna have this was gonna be over 2. Okay, what do you mean? 2 plus 1, what do we get? Hello?
Akuzwakali iyakhatha.
9/2 plus 1, what do we get? You
11/2.
hear me now?
Yes, sir.
11/2, and then if we say 9/2 minus 1, what do we get?
7/2. It's 7/2, sir.
Okay, and then for what's this? 3/2 plus 3, what do we get?
9/2.
9 over. When you add here, not multiplying, adding.
Yes, sir. When you add, you get 9/2.
3/2 plus 3.
Yes, sir.
Okay, that's weird. All right, and then when you subtract,
Negative 3/2.
negative 3/2.
2.
It's not about telling us what we are looking for. Right, so let's refine. Another way. Hello? Hello? Can you guys hear me?
No.
Yes.
Yes, sir, but you can't see the calculation.
I lost people there for some time. Those values are looking for. Can you see my screen?
No, sir.
Yes.
Okay. Okay, let's try doing this again.
Yes, sir. Now I can see it.
Able to see it now?
Yes, sir.
Right. Because here I'm not doing this. Okay. Our calculation is not happening here. Our calculation is not happening. We need a different approach for that point of intersection because this is failing to be factorized. None of these are giving us that, this 9/6. So we need a different calculation. Let's see. But I don't like the assumption I'm about to use. That this is in the middle of BW. I don't like that assumption. But we might have to use it. All right. So let's try a different approach. So we're looking for the coordinates of C. That means we need to try and get the coordinates of W here. Coordinates of W, the coordinates of B over here, and then assume that it's in the middle of those two. Let's try it and see if that point actually falls on the line. All right. So for W, it's going to be the x-intercept. We let y to be 0. We are having y is equals to 2 over 3x plus 2. So this will be 0, it's equals to 2 over 3x plus 2. So this will be minus 2 equals to 2 over 3x. This will be 6 it's equals to 2x divided by 2, divided by 2. Our x value ends up being minus 3 like that. So that means the coordinates for W, it's minus 3 and 0. Right. And then if that's minus 3 and 0, and then we are saying that the distance between W and B, it's in the center of it. That means the x coordinate of C has to be negative 3 over 2. Like that. It has to be that point. But now, it looks wrong, this thing. But okay. Yeah, we can use that. So we just need to find the y coordinate of it. Y, we can substitute this C coordinate, so sub C into what's this? Into f at x. So we have y, it's equals to it was what was our equation for f? 4 over 9. How were they expecting you guys to get this? Negative 3 over 2, like that. And then our y coordinate, this is squared. So it's going to be 4 over 9. This will be 9 over 4. And then our y value is equals to 1, like that. So that means our c coordinate would be negative 3 over 2 and 1. How on planet Earth were they expecting great terms to find that? All right, next they're asking us to find the length of WO. We now know the coordinates of W, which was negative 3 and 0. So from here to O, you just move 3 units. So this is just 3 units like that. Next, you're told that D and T, where are those? D and T, there's D, I can't see T. Okay, that's fine. It's not given. Are symmetrical about the line y equals to x. So the line y equals to x is somewhere like that. D is over here. So it's symmetrical. They are symmetrical about that line. You're supposed to write down the coordinates of t. So that means for us to get t, it has to be a reflection about this line, which is so that coordinate becomes the y coordinate becomes x coordinate. So that means t will just be 4 and 3 like that. That's it. So the coordinate for t here is just gonna be 4 and 3. That's what you get when you reflect about the line. Let's ask you to reflect about the line y equals to 0. They are asking you to reflect about the x-axis. For x equals to 0, that's the y-axis. Right, any questions? Hello?
No, sir.
Right, I hope this recording is still recording. All right, last question. It's for 8 marks. We are asked to find the point of intersection of that graph and that graph. Graphically, we're supposed to show all asymptotes as well as the x-intercepts and y-intercepts were applicable. So basically, they're asking us to draw these two graphs accurately. So firstly,
sicela usendele enye i-past paper after la if vele ubongeke uyisende.
you guys are not writing these past papers.
This
This is the second, if not third paper that I've sent you guys, and you guys are not returning. All right, let's
So please send the memo for this past paper.
do we have memos? I'll try and look for one. All right, let's see here. So here they're asking us to find the point of intersection of those two lines. So this one is an exponential. This one is a hyperbole, right? So I draw, if they're not gonna give you a graph paper, remember, when I have your nice line, when I have, these things have to be 1 centimeter apart. So on your ruler, make sure these are 1 centimeter apart. Also the vertical line, the points over here have to be 1 centimeter apart. like that. Right. So firstly, you have to find your asymptotes. So asymptotes for this one. So x-intercept, not asymptotes. Let's do this. Let me try and plot this quickly. It won't be accurate because I'm not using rulers and stuff, but we will draw them using that graphing calculator that we have. So for this one, the asymptote you have is y equals to 1. So y equals to 1 is over here somewhere, y equals to 1. So that means we will approach this line, but we will never touch it for that one. And then the y-intercept, so we don't have an x-intercept here. So the y-intercept, not x, you let x to be equals to 0. So that means it will be y equals to 3 times 2, 0, plus 1. So it will be y equals to 3 plus 1, y equals to 4. So that means your y-intercept, it's somewhere here on 0 and 4, like that. And then I'm guessing this is how your line is supposed to go, right, for this one. This one, let's see the asymptotes that we have. It's still x, it's still this one, y equals to 1. The other one is this one. And that means we'll end up having, it's going to be somewhere here and here. That's going to draw them. Difficult not having the graph paper. Let's get the graph. Calculate. So graph is supposed to draw 2, 3 times 2 exponent x plus 1, like that. That's that graph that we have here. The other one, it's y, it's equals to 6 over x. 6 over x plus 1, like that. So it's on the other side. All right. So these are our two graphs, like that. So the points of intersection that you're supposed to, or the points that you're supposed to show on your graph there, are supposed to be, you're supposed to show this x-intercept for this one. You're supposed to show the y-intercept over here, which is 0 and 4, like that. You're supposed to show, give them this point over here, which is the point of intersection, which is 1 and 7. Is there another point of intersection? I doubt. So the point of intersection is just going to be this 1 and 7 over here. That's what they were looking for. So when you draw your graph, make sure your spaces are equal and try to show that point over there, your asymptote over here with the line y, it's equals to 1. So it's that line that's your asymptote. The other one is x equals to 0. That's your other asymptote. So make sure you show those. What else did you ask for? Yeah, just those, like that. Any questions? Any questions? All right, if there are no questions, that's the end of that question paper. There's someone who said they had a question, or have they asked that question already?
Yes, I did ask.
Okay, so I'll send you guys another question paper Okay, yeah. I'll try finding another question paper and send it to you guys. Hopefully people will do the question paper. Yeah. So there are no other questions. We'll continue tomorrow then. Bye-bye.